Hi everyone, welcome to our video on the introduction to antiderivatives. So antiderivatives is just the reverse of doing a derivative. A function f is an antiderivative of little f on an interval I if f prime of x equals little f of x for all x and I. So that's kind of a short formal definition. So let's see how it works. So on example 1, we're just going to find the derivative, something that we've done before with all of these functions. And well, it's really just the power rule for all of them. So it looks like with this, we could do f prime of x. So I'm doing capital F prime of x would be 3x squared. And then the second one is also, well, looks like it's the same. F prime of x is also 3x squared using our power rule. And then this last one is also, so f prime of x, the capital F prime of x is also 3x squared. Okay, because the derivative of constant we know is 0. Okay, so in example 2, it says find the antiderivative. So it's the reverse of what we just did. So we have these answers from before, and we're going to reverse the process. The way that we write the antiderivatives is we do a capital F of x like that. And then while the reverse process is looking like this should be just x cubed. But, so notice this derivative matches all these f primes. Okay, so it is the reverse of what we just did. But notice that our original f capital x here, the capital F of x in example 1 had 3 scenarios. Where on this, all I have is x cubed so far, so it only matches that first one. It doesn't match the other 2. Well, what we do to make sure it does make a match if needed, if we have other information, is we add this constant plus c, where we do this capital C. So this is just some random constant. Okay, and we could always just quickly check doing this derivative of this function that we just found is 3x squared. So it's always, we can go back and forth, just kind of like how checking division, we could use multiplication. Okay, so this is the most general antiderivative of little f, is our capital F of x plus that constant. And so it is just the reverse of what we've been doing with derivatives. Here's our most basic forms, where we have our function, and then we have the general antiderivative. So little f of x equals a constant would have the general antiderivative of kx plus the constant c. Okay, so kx plus c. And one way to think of this is to go from this right column to the left. If I were to do the derivative of kx plus c, I would get just k. Okay, so this going this way is doing the derivative, and that's the way to check it. So from right to left is derivative, left to right is antiderivative. Okay, so we can always make a check for it. Our power rule, okay, so here's our power rule. So x to the p is equal to our antiderivative here. And our power rule in words is in the reverse of our derivative. So what we do first is we would add 1 to the power. And then the second thing we would do, then we would divide the front by that new power. Or let's say multiply front by reciprocal of new power. So this is our power rule for the antiderivative. And we'll use it real soon in this example, but this is it in words every time. And then our other two common ones, the f of x equals e to the x has the same antiderivative, just we need to make sure we add c to it. And then our 1 over x, so this is a special case, so it doesn't match the power rule, because if we try to add 1 to negative 1, we get 0, which means that we have something weird happening with our power. So instead, we know that it would be the natural log of x plus the constant. And again, remember, if you check, going from this right way to the left way, this is doing the derivative. We know the derivative of the natural log of x is 1 over x. Okay, either way, we'll always check our answer by taking a derivative. All right, so let's actually apply these in this video. So these are both power rule problems. All right, so we need to find all antiderivatives of the following function. When they say all, it just means you're doing the f of x plus c, f of x equals the answer plus the constant at the end, and then we'll check our work by doing a derivative. Okay, so with this problem, So there's not much going on with it. Let's just break down our steps here, the 1 and 2. It's the power rule. So capital F of x, so this is now the antiderivative, equals, I usually leave a little space after the equal sign. Let's add 1 to the power. So add 1 to 12 would be 13. And then we're going to multiply the front by the reciprocal of 13. So that would be 1/13. And then we just have to make sure we add a constant at the end. Okay, so that is our answer here. And then a quick check. And you could often just visualize it. Well, 13 would go to the front. So that 13 and that 13 would cancel. So we'd have 13 over 13. And then x to the 12. And then so the 13s cancel. X to the 12 matches our original right there. Check. Derivative of a constant is always 0. So we have this arbitrary constant where if we take the derivative of it is always 0. Okay, so in number 2, just like derivatives, it's usually best to rewrite it before we do the power rule. So this is x to the -6. And then I'm just applying my steps for the power rule. I'm going to add 1 to the power. Let me do it in blue. So I'm going to do capital G of x. So this is the antiderivative. So capital G of x. Apply the power rule. Add 1 to the power. So that would give it a power of -5. So if I add 1 to -6, I'm at -5. And then multiply by the reciprocal of this new power, which would be 1 over -5 like that. However, I'm going to erase the negative down below. Typically, we'll just put it in the front or in the top like that. And then still plus our constant c. And there we go. So that is our antiderivative. And again, a very, very quick check. You could visualize it. I'm going to just write it in red. The -5 would multiply the -1/5. And then we'd minus 1 from the power like that. And then, yep, and the derivative of a constant is 0. These just cancel. The 5, -5, all that's gone. So I'm just scratching it out, getting it messy. But we would see that we're left with our original. Yep, so it matches. Okay, so that's our introduction. I'm going to put a pause on this. In the next video, we'll do a bunch. But our power rule is kind of the main one. And then we'll just make sure we see these when they start to come along. Okay, so that's that. If you have questions, please let me know. Otherwise, thanks for watching, and I'll see you again.